The assessment for day 8 pulls together everything that we've done to try to give you a chance to demonstrate your mastery of a whole bunch of little skills that I've asked you to work on. As it states, you've got a set of dice rolls, and you suspect the dice might be biased in some way. In other words, it's not a fair die. A fair dice is one in which if you roll it, each value from 1 to 6 has equal chance of appearing. And you start with a set of rolls. Ignore for now how you actually got those rolls. Let's just assume that it's an accurate value. And so here is a result list that contains a whole bunch of rolls. When I run these, I can say, well, how many rolls do I have? I've got 5,000 rolls. What are the rolls? I guess I could print them all out, but that's not relevant to see them all one by one. I need to come up with a strategy to figure out how to proceed. Now, in solving this problem, we're going to use a template that I've started to use on a number of these questions. First, you have to identify the input. Then try to figure out what kind of variables do you think you need to solve the problem. Finally, based on the problem, there's usually a structure that comes in mind. And when I figure everything out, I've got to try to determine what the output will be. So when you are faced with a task, before diving into the programming, try to think about how you would solve this. And if you had no choice but to spend 30 minutes or waste an hour of your day to try to figure out if these dice rolls are biased or not, I think you would start by saying, well, I got to find some way to count how many times a 1 appears and count how many times a 2 appears, and so on. Well, this is something that you can do with a program. And what I'm going to do is show you some of the thoughts and the processes that go behind writing code from scratch, which is, after all, the thing that I want most for you to learn in this course. I've got an analyze dice method ready to go, but it doesn't do anything yet. So let's make some ideas here. What if you could count the number of 1s, 5s, and 6s? If you actually had all those values, then maybe you could try to find a way to explain, is it biased or not? I think we have to look at that notion of bias and say, well, it's a little ambiguous right now, but until I get my count, I really can't proceed. So my first check is, well, let's figure out how I could count. And then after I'm done with that, present results to user so they can make informed choice. After all, a program might not have all the intelligence to determine this, but if the information is presented to a user, maybe she can figure out, yeah, this is something that clearly shows that there's a flaw in the die in some way. So how would I count a certain value to see if it's in a list? Well, we've kind of done that already in some of our lecture exercises. Look at some of the things that you see here. If you really were asked to count these, you would probably have a little piece of paper and you'd mark down a box where you keep track of your 4s, the 3s, the 6s, and so on. And you would say, I've seen a 4, now I've seen a 3, oh, that's my second 4, that's my second 3, and so on. So you might find yourself doing something like this. Count 1, I don't have any 1s yet. Count 2, and so on. Now this is going to give me variables to keep track of all of the different dice rolls that I expect to get. How do I count all the 1s in this list? Well, I know that I have the ability to write a for loop, and in fact my for loop could be used to print every element in the list. But this time, instead of printing every element in the list, I want to just count how many times I saw a 1. So let's say for every roll in results, I want to do something. Well, we'll first start with the obvious starting point. I'm just going to print out that roll. And my result will look like the following. Nothing too helpful, it just prints them all up one at a time. So at least I know I've got code that runs. Again, a good strategy when working on programs. But now I want to do something else. If it turns out that a particular dice roll is equal to a 1, then I can say that I need to increase the number of counts that I've seen for 1. Well, count 1 is how many times I've seen a 1 so far. I'm going to let count 1 equal count 1 plus 1. This is the assignment operator you've seen me use before. And it's not mathematical, it's computational. The new value of count 1 is whatever the old value is plus 1. And then I'll just say print, and I'll say I saw count 1 values seen. Run that. And I do my analyze dice. So I've seen 809 values. Well, is this fair? Biased? Well, if I've got 5,000 and I want to know how many times I'm going to see an individual number, well, 833 is exact. But as you may expect, when you're dealing with statistics and independent trials, it's unlikely that you will have exactly 833 ones, 833 twos, and so on. So I don't yet know if this is a biased or unbiased dice, but I do have at least now the total count of ones. Now, I could look at this further and do the exact same thing. Well, what if it turns out that the roll is equal to 2? Then count 2 is equal to count 2 plus 1. And you can see where this is going. This will give me a program that will actually work correctly, but we may find it's not as elegant as what we would like. Let me run my dice again. I saw 809 ones and 829 twos. All right. So I could take this one step further, and actually 4 steps further, do this for 3, 4, 5, and 6. But instead, I want you to think about the power of a for loop and the power of the lists. If I know I want to keep track of 6 pieces of information, count 1, 2, 3, 4, 5, and 6. You should at least recognize that these are all related to each other. In fact, what I really have is I've got a list of counts. I've got 6 different values, and one of them is keeping track of the 1 counts, one is keeping track of the 2s, and so on. It's not that far of a stretch to say, what if I have a list counts, which will keep track of all the values that I'm looking for. Initially, there are 6 values in counts, because after all, there are 6 potential dice rolls. And by doing this, the first thing you should see is that your code is smaller. The second thing is it's easier to read because I've grouped together into one list what used to be 6 different variables. And if you see a bunch of variables, you may not understand how they're related. Are they all the same in some way? Well, by putting it into a list, you're grouping it and making it clear that these are all related in some way. And then I look at what's really going on here. If roll is equal to 1, I want to increment that first value because that's the one that I've seen. If roll is 2, I want to increment the second one that I've seen. What we want to do is to, instead of having different variables now, let's use this list to accommodate all of our information. If you just make a small little change here, you can see that what I want to do is update the 0th entry in counts, because that's what I'm using to keep track of my ones. And the first entry in counts, because that's the one I'm using to keep track of my twos. If you go down the list here, you can see that all I've done is make the corresponding changes to my code. I have no new functionality. It still only counts 1s and 2s, but let's look at it. So I get the same output I did before, and this is quite common in programming, where sometimes you find yourself cleaning up your code just to make sure that it looks better, and you still expect the exact same results. But now we're ready to finish this assessment. Look at how similar this block of code is, which checks if you're a 1 to increment the counts of 0, and this one. In fact, you would probably copy and paste this for 3, 4, 5, and 6. And when you're a programmer and you find yourself copying and pasting code, the first thought is, well, maybe there's some pattern I can take advantage of. And when you're done with this, you may be amazed to see the following. I only need to write one line of code here. let's see what's common. If rolls is a 1, I want to increment counts of 0 by 1. If roll is a 2, I want to increment counts of 1 by 1. If roll is n, I want to increment counts of n minus 1. So hold that thought for a moment. This is what you do if roll is a 1. This is what you do if roll is a 2. So in the general case, I increment count of roll minus 1. Each time through the loop, it takes the respective values of result. 4, then 3, then 4, then 3. And it increments the count associated with 4, the count associated with 3, and then the count associated with 4. So I can actually get rid of all of that. Now, down here, I'm only showing information for 1s and 2s, but I actually have all the information. In fact, let's even be simpler and say, you know, now that I actually have a list called counts, and I've incremented each one, now I can actually try to understand, well, is this a valid or unbiased dice? When you look at it, the first 4 values seem to stand up nice. They're in about 833 plus or minus some range. But something goes horribly wrong here with 5 and 6. In fact, it looks like some reason the number of 5s is much lower than it should be, and they've been replaced for whatever reason by a number of 6s. This looks like a dice that is biased to have more 6s than 5s. And you might not notice it when you're just casually looking through these numbers because there's so many of them. But when you look at the sums, clearly there's an issue. So this is the way you would normally end this particular assessment. If you have installed PyLab, let's go one step further and show what I can do with this information. If you do have PyLab installed, you can say import PyLab. And PyLab has a number of abilities to plot information. And I believe there's one called plot bar, plot bars, plot columns. I'll figure it out in a moment. Let me pause the video and come right back. Yep, it was just PyLab bar, which gives you a set of values and you can plot them. So if my analyze dice, instead of having it print the counts, let me have it return the counts. Again, this is one of the differences between printing and returning, is that when I return information, I can actually do something with it as a program. And what do I want to do? I want to plot the results of running analyze dice. I need 2 arguments. That's right, I need to do the x values as well as the y values. And again, I know that because if you look at this, I need to have a sequence of values that are the x and then the heights of the bars. Well, what's nice is that I know what my x values are. It's the range of 1 to 7. Those are the dice rolls 1, 2, 3, 4, 5, and 6. And I know what my y values are. That's the values I get back from analyzed dice. And when you look at this, it sure looks to me like there's something fishy going on. So this concludes the assessment with PyLab involved.